This is SAT Practice Test 3, the Math Calculator section, question 34. So, in a circle with a center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by the central angle AOB is what fraction of the circle? So first you can start off drawing a diagram if that helps you, but for the sake of this video I'm not, because doing the diagram is just going to waste your time. It's asking you the area of the sector formed by this angle, by the central angle AOB, and what fraction of it is the area of a circle. So what it's asking us is area of a sector over area of a circle. That's what it's asking us. Now I'm just going to color code right here. And it's important that you guys know the formula. So right here I'm going to write the formula for the area of a sector. So area of a sector is, x over 2 pi times pi r squared. And then the area of this one right there is just pi r squared. And a lot of you are going to wonder, what is x? Well, x is this thing right here. So what x is the 5 pi over 4 radians. You can solve this two different ways. You can either stick with the radians or solve for degrees. I will show you the degrees in a second, how to solve with that. But it's the same way. It's going to give you the same thing. But I suggest sticking with the radians because it's way much easier. Because it's already given to you, so you don't have to calculate even more. So now let's solve this. So pi over pi squared. I'm just going to write that at the bottom. So 5 pi over 4, 2 pi, times pi squared. Okay, so a couple things cancel off. This cancels off and this cancels off, right? Now we're just left with 5 pi over 4 over 2 pi, which can also be written as 5 pi over 4 times 1 over 2 pi. You can see that the pi's cancel off. Now you just have to do a little bit of multiplying, and your answer is 5 over 8. Let me show you how to do it if you're converting the radians into degrees. So if we're going to be converting the radians to degrees, we're going to be doing 5 pi over 4 times pi over 180. Since this is a calculator section, you can use your calculator, but you can see that the pi's cancel off. And when you multiply and divide, you get 225 degrees, right? So that's now your theta value. And we're not doing radians, we can't really use this equation, can we? We have to change the equation. It's going to be pretty much the same. I just have to change this part. And it's going to be theta over 360 degrees. That's what it is going to be. It's the same exact thing. It's the same thing, but you just did theta degrees over 360 degrees. And your theta degrees is your 225. So now let's solve it. You're still going to get the same answer. So you do pi r squared, 225 degrees over 360 degrees, and then times pi r squared. And then the pi r squares cancel it out again, and then you're left with this fraction, 225 over 360. Okay, now we just have to simplify this fraction. So we can divide by 5, or you could be using your calculator. So this is 45 over 72. We can simplify even further. We get 15 over 24. And then simplify it one more time. And then we get 5 over 8.